All right, good morning, everybody. So someone just asked me in chat what I mean by all the default option with a DCC compiler. I have no idea what that's in reference to, but in general, when I asked you to write code that runs on the server, I want you to compile it with just GCC as opposed to putting in, C99 option switches or turning certain things on and off or things like that. Just plain old GCC. So whatever that default is on the Linux server, that's the version of C, because C comes in a variety of flavors and variants, and you can turn these on or off by setting switches on the compile command. So if that was in specific to something, if that was in reference to something else more specific, let me know. All right. Week 6, welcome. We are about halfway through. We've got 6 full weeks of classes left, minus, 3 days over Thanksgiving, and maybe 1 or 2 other days. So we're about halfway through here. I finished grading the midterms around midnight last night. Those are posted on Canvas with lots of feedback for where deductions occurred. My plan is to take tomorrow's class time to go through the exam in detail and talk about specific things I saw on different questions and so on. But as I said in the announcements, if you have questions about the exam in general that you want to talk about, you can ask about those in class right now or tomorrow. If you have questions about your grade, about why, I took points off or something, or what a comment means, feel free to come to office hours. Sooner rather than later, because we're getting into registration time, and so office hours are starting to get visited by people looking for advising on courses, so there's competition there. But if we get to a point where, I've got nonstop students for all of my office hours, then I'll consider adding extra hours just for this class. Okay. But let's see how it goes. So with all of that preamble, any questions up front? I'm going to go through the ODPs next, but any questions up front? Will the midterm be unlocked so we can see our answers again? I didn't know that they were locked. So you cannot look at your answers right now? Interesting. Yes, I will go ahead and do that. I'll figure out how to do that. Yeah, I'll do that later on today when I'm done teaching, which is like after 4 o'clock. Because I want you to be able to see your answers, otherwise my comments make no sense. So yeah, thank you. I'll figure out how to do that. All right, other questions? All right, let's talk about ODP 408. So we're back to ODPs. And as I mentioned in the announcement, right, it's really important that people work on these. This is a really powerful way to kind of force you, or compel you at least, to write pieces of code to go along in parallel with what we're talking about in lecture. And the more effort you put into these, the more you'll get out of them, right? If you find some code and try it and it works and you get 10 out of 10 on your ODP, that's great for 10 points on 1 out of 30 assignments. That counts a few percent of your grade, but it's not going to teach you anything, right? So embrace the struggle here, right? And like I say, if you have questions that can't be asked in class, if they're specific questions on the ODPs, you can send me email for help, okay? But it's got to be more than 2 pages of code and saying this code is perfect, why don't I get 10 out of 10? Okay, I want to see how you're working the problem, how you're going about trying to find the issue, how you're testing it, debug statements, things like that. So let's look at 408, which is due tomorrow morning at 8. So you're writing a complete C program. Okay, it's got to be in C, not a bash script. Takes one command line argument, which you can assume is a valid double precision real number, and prints out its square root. Okay, and compile it just by saying gcc-o output name, source name, and put a -lm at the end. That links in the math library, which is where the square root function is found. Oh, hold on. My roll call did not work. All right. So GCC program.c -lm, the -lm links in the math library that contains the square root function. In your main program, you need to include angle bracket math.h that prototypes the square root function. And just use doubles, don't use floats. Okay. Assume a single command line argument, which is not negative. It's a valid real number, so you don't have to do any error checking. Scan it with a %lf. Okay. And since I'm telling you that it's a valid floating point number, you don't even have to check the return value from scanf. Okay, you can just assume it's going to parse successfully. Use a square root to find its function, and then print it out with the exact string, quote, %lf \n, close quote. Okay, so there's no extra spaces, there's no extra new lines, just quote %lf \n. If you do that, it should assess perfectly. And a bunch of people have already done that, so the assignment seems to be set up correctly. Alright, so this is playing with square root function, but mostly it's playing with parsing command line arguments. And remember, so far what we've been doing, what I've been talking about again and again and again, was this idea of when you want to read user input while the program is running, you use fgets to load the user's input into a string, and then you use scanf to convert that string into typically an integer or something like that. Okay, that's if you're doing runtime input. If you want to parse a string in general, whether it comes from a file or a command line argument or fgets, right, scanf is the parser. So you can take an argument like argv_1, run that as the first argument of scanf. And for this ODP, you can assume that there is a single command line argument. So you don't even need to check argc, right? You can go directly and just look at argv_1. But if we didn't have that assurance that this had a command line argument, what would we do? We'd have to check argc and make sure argc is at least 2 before we do that. Everybody nailed this on the midterm. I was so happy with that. Everybody checked argc before using argv, which was fantastic. That's usually something by the end of 222. I'm still trying to get students to check argc. Everybody seems to be doing that, so that works great. Let's see, question, what is angle bracket CMath? I'm going to guess complex, but I don't know. I don't know if it's a standard part. Try including it, and if it exists, check /user/include. But my guess would be it does complex numbers, but I don't know. Alright, so, oh, CMath is the C++ library. Okay, cool. All right, so that's ODP 408, and that one, you know, you're writing a whole program so you can test it yourself and see if it works. And honestly, I think the trickiest part may be making sure that you print it exactly with this string. Because if you use %G or %F or you put spaces in or something like that, it won't assess correctly. Okay, so make sure you're doing that for the output format and this for the input format when you scan. Tomorrow we'll talk about 409, but you can already look at it on /temp. It's already posted. Just don't assess it until assess actually says, you know, you're assessing for ODP 409. But 409 is going to be the same thing, but with tons of error checking. Okay. So we'll talk about that tomorrow. But if you want to get a head start, 409 is like 408, but with error checking. And then 410, which I'll post on Wednesday, we're going to start digging deeply into string processing, which is what I want to work on today. All right, questions on any of that? All right, we started to do this last week before exams came along and stuff. I want to work with dealing with strings inside a C program. So let's try something. Go ahead and log into the Linux server and run the command answer, and let's try to do some interactive stuff. And yeah, question in chat, are we continuing with C or swinging back to Bash? We're going to do a few days of talking about string processing in C, and then we're going to go back to Bash. And I want to talk about the file system, I want to talk about processes, GDB, symbolic links, awk, sed, regular expressions, a whole bunch of stuff that's more sort of Bash or Linux oriented as opposed to just C. Up to and including associative arrays in Bash, which will be a cool topic. And then, time permitting, we'll come back to C and we'll talk about some system level stuff, processes and forks and exec and things like that, just to touch base on them. All right, so I'm posting a test question here on the answer system. So if you run answer, you should see a question pop up in your screen, and it should look something like this. It just says, what is your favorite color? Cool. All right. So that's working. So go ahead and answer that. This is just our kind of heartbeat check. And after you type your answer, you can, if it works for you, and I guess it doesn't always work in Windows, but you can click on the submit word, or you can hit a tab to go down to submit and then just hit a space bar. And that's how these dialogues always work. And if you want to clear your text completely, you can hit the clear text. And then submit to submit. And once you submit, it will say waiting for a question. All right, we got 22 responses and we got 24 people in class, so that's pretty good. All right. All right, cool. Got a quorum. Got a actually 100%. So let's write a line of C code here. So you have a string named temp and you have a character named C. Show me one line of C code to set C equal to the first character of that string. So temp is a string HELLO, for example. And remember that, we define strings to be a char star, or sometimes, if we know how big a string is and we want to allocate space for it, we might say char variable name bracket and give it a request for space. Either way, temp is an array, regardless of how we define it. It's an array, which means we can access the elements of it using angle brackets, which is what people are doing. So in C and most other languages, the array index always starts from 0. And this is contrary to, the way that we learn to count. We always start from 1. Earlier languages like Fortran started indexes from 1. But if you start counting from 0, a lot of things become really easy. And if you start counting from 1, there's some things that become very complex. So I used to work in a language called APL, and it had a variable. It used Greek letters, so there was a quad symbol followed by IO. And you could set this to be 0 or 1, and that would say whether your array started from 0 or 1. That was kind of cool. That was sort of a transitional period. But C arrays always start from 0. So this first character is actually going to be temp bracket 0. And if we want to set a character C equal to it, right, it would be character C equals temp bracket 0. Right? And we would not want to say character star C, because this says C's not a character, C's a pointer. But this thing is a character, so we're trying to take a character and assign it to a pointer. That's not going to work. Okay? But this is a character, so we're doing character to character. So that'll work fine. All right. So, what if we want to write a line of C code to set C equal to the last character of the string? And so the first character was 0, the second character would be 1, the third character would be 2. We just need to know the index of that last character. And in this case, my test string was 5 characters long, and there's a string length function which tells me how many characters I have. 1, 2, 3, 4, 5. But because we start from 0, the 5th character is index 4. The 10th character would be index 9. The first character is index 0. So the nth character is at index n-1, where I mean by nth the usual way that we speak about, the first, the second, the third. And if our string has 5 characters in it, the last character is the 5th character. And yes, string length gets used just like this. So this takes a string and it returns an integer. So I'm getting a variety of answers here, all of which are plausible. And we want a general case. If our string is hello, then it would just be character 4. but we want a general case here. And we need to be very explicit with C. Remember, computers don't really have a lot of intuition, so we need to spell things out for it. So we could do something like this. Right? Take the length of this string and save that in an integer. And then character C equals and just grab the character at that index -1. Or you can do it directly in place. You could just do C equals temp bracket string length temp -1. And this is something that works perfectly fine in most languages, including C. And if our computers thought more about what we asked them to do, this might not work. But there's no deep thought going on the computer's part, so this will be processed very programmatically, which is, first it's going to evaluate this side. Whatever it ends up with, it's going to assign that to C. So how does it evaluate this? Well, it knows it needs to find an element in this array, and that element is whatever's inside the brackets. So first, it's going to evaluate what's inside the brackets. And it's going to basically go left to right. And the first thing it's going to have to do is call this function named string length and pass it an argument of temp. Okay, the fact that there's a temp here never even occurs to the CPU. Okay, it's not even going to think about that. It's just going to say, hey, okay, here's a function called string length. I have to pass an argument temp. So it'll put that temp somewhere and it'll call string length, and string length will pick up that argument and it will do its thing and calculate the number of characters in that string and return it. And then this piece of our expression gets replaced by a number, whatever number string length returned, which should be the number of characters. And then it's going to take that number and subtract 1, it's going to get a new number. And then that new number is what it sees inside these brackets, and it says, oh, okay, I'm looking for an element in this array. Which element? Well, that number that I just computed. And it'll take that element, use it to index one character in this array, and then it'll set C equal to it. Right? So you can do this in steps, right? I could even have done, len equals string length temp, and then done len equals len -1, and then done character C equals temp bracket len, which is really what's happening in this, right? But if we put it together like this, it'll get taken apart and it'll basically do those steps. It just doesn't use an explicit temporary variable, but it does use a temporary variable internally. So speed-wise, one is not better than the other. If this makes sense to you, absolutely do it like this, right? If this tickles you in a good way, do it like that, right? If you sort of like the succinctness of this, go for it. All right, let's see what else we got here. Good. Okay, and it is string length -1 because we start from index 0. And good test case was, just make a string like hello. String length is 5. If I set element bracket 4, if I grab element bracket 4, that's going to be this. This is 0, 1, 2, 3, 4. That's the last character. All right, and if you fall behind on the questions, just go ahead and hit submit, and it will pop you to the next question. Let's see. So I'm missing some stuff in chat. What's the purpose of this? That is anonymous. Yeah. So normally I would have people go to the board in the classroom and work these things out in groups. and that's better than just sort of talking about the stuff. But that's also kind of hard sometimes for people who aren't sure about how to do this stuff, especially if you're in a group with people who act like they know what they're doing, or maybe do know what they're doing. So yeah, this is kind of a safe way to just throw some stuff out there, and I'm not going to call people out on it, and show people each other's answers or things like that. But it's a way for me to sort of get some feedback on where people are. All right, and we'll get to the null terminator in a second. So yeah, let's talk about the null terminator. If your string is hello, there's always a null terminator at the end if it's a proper string. And so this is element 0, 1, 2, 3. The last character of our string is at index 4. The null terminator is at index 5. So the string length does not count the null terminator. Okay, the string length is the number of characters up to but not including the null terminator. So for hello it's 5. But if we wanted to find the null terminator, it would actually be this. Right? It'll actually be the character at the position given by string length. And the edge cases, if you have a totally empty string, the string length function will return a 0. And if you were to look at element 0 of that empty string, it is defined, it contains the null terminator. All right, so yeah, this brings us to sort of the point of this, which is if you use fgets, and you type in hello followed by an enter key, your string looks like this, HELLO followed by a new line and then followed by a null terminator. All right, now if that's what my string looks like, string length is going to be 6 because it will count the new line. String length counts everything except for the null terminator, everything up to but not including the null terminator. So string length here would be 6, which means if I wanted the last character, I would look at string length minus 1. That would be my new line. Let's see, I think we might have crashed the server. This is cool though, we got 30 people logged in. And, oh, we're not even touching the CPU. That's good. All right, cool. So, so this leads us to another sort of final question here. And this was something we talked about last week, but let's do it again with what we've just been doing. Suppose I wanted to get rid of this new line and change my string from a hello followed by a new line to just hello. And I'll give you the trick, right? If we were to just change this \n to a \0, that terminates the string right there. And my string looks exactly like it did before, except it ends where the new line was. So it's just everything up to but not including the new line. And remember, if we use string length, it includes the \n. So think if your string was this, and I wanted to remove that last character, it's going to be exactly the same code as if my string is this, and I want to remove the last character. Don't think of the new line as doing anything different from any other character. It doesn't affect string length. It doesn't require any special treatment. We'll get 2 more answers in, and then we'll talk about it. All right, so so if you wanted to do let's say temp was ABCD, your array, because a string is an array, looks like this. To take off that last character, which is a D, we want our string to look like this, our array. We want to leave these, but we want to throw a null terminator in here. And we don't really care what happens after that, because to see a string is a set of characters up to a null terminator, and that's where the string ends. So it doesn't matter if we have letters or characters or null terminators or unprintable ASCII codes or whatever, right? Our string is going to end right here. So how do we make this happen? We got to do this replacement. In this case, we have to take character 3 and change it to a null terminator. So if our string was called temp, we just need to set one character equal to the null terminator. We need to know what index that character is supposed to be at, though, right? So string length is tied into this. In this example, string length of temp is 4, and the character that we need to replace is 3. And this is the same thing we were doing a few moments ago when we were saying what's the index of the last character. It looks like it's always string length -1. right? First character is always 0, second character is always 1. Last character is the number of characters minus 1. And the number of characters is what string length tells us. So if we did string length of temp and subtracted 1 from that, and use that to index temp and set that equal to \0, that'll get rid of the last character in any string. And it doesn't matter if that's a null terminator, or if it doesn't matter if that's a new line or the letter D or something else. This will always get rid of the last character of a string. All right. But if you got your string using fgets, right, we know that fgets always throws a new line at the end of your string as long as it fits in the buffer size that you specified. And so if we want to get rid of that new line, this works for that also. Alright, so let me post that piece of code, and let me ask you, when is this going to get you into trouble? When does this not do what you want it to do? So it takes off the last character of the string. All right, we've got some answers coming in that are spot on. All right, so yeah, consensus coming in. So this is related to an edge case. So some people are saying if there's no null terminator at the end of a string, well, if there's no null terminator, you have a bigger problem, which is you don't have a well-defined string, which means string length, who knows what it's going to give you. It's going to give you how many characters there are in the memory of the machine from the start of temp till it happens to find a 0 stored in memory. And, you know, that typically is, you know, something longer than what you wanted your string to be. There's a chance that it will go into memory locations you don't have access to, and string length will segfault. But it's more likely that string length will come back with some weird number, you know, like 117. And if you think that this is a string and you try to print it out, you're going to see all kinds of weird stuff printing because it's not valid. But assuming that there is a null terminator somewhere, that this string was well formed to begin with, the reason you get into trouble here is this is trying to remove the last character of the string. Well, if temp doesn't have any characters, if it's just an empty string, then it doesn't even make sense to say let's remove that last character, because how do we remove the last character? We go one spot before the null terminator and change that to a null terminator, right? This string length temp gives us the index of the null terminator. When we subtract 1, it gives us the index of the character before the null terminator. Well, if temp bracket 0 is 0, this is an empty string. What this is going to do is try to take the character before this and change that to a null terminator. Well, this is the first character in the string, so what is the character before it? It's basically temp minus 1. And if we change that, who knows what's going to happen? It's not part of the array. Ooh, my scrolling function works. And so yeah, so this there's a good chance it will seg fault. If you have stack smashing protection on or something, that may pop up, or it may change the value of some other variable on your stack, right? Something that was declared shortly before temp. It can have all kinds of strange effects. And so if you're going to do this, right, and you don't know absolutely for sure that you have at least one character in this array, you'd want to check that first. Now, if temp came from fgets, and you're allowing 100 characters to be stored in there, you're guaranteed there's at least a new line at the end. If they typed in more than 100 characters, the last character might not be a new line, but then you'd have 100 characters. But if this is a command line argument or something that was given to you by some other function, you would want to check to make sure this string is not empty before you do this. Otherwise, potential seg fault. All right, cool. So yeah, somebody mentioned in chat a parse function that they wrote, basically scanning for an integer, calculating how many digits that number has, and then checking for a new line at the end. That's a very precise way to parse an input. And if you were to try to write a scan function yourself, those are the kinds of things you would be doing, right? And you can try to imagine what it means to be an integer. It means you have an optional plus or a minus sign, followed by a succession of things, 0 through 9, followed, well, if it's coming in from an fgets, followed by a new line. But there's also optional white spaces, and a new line is considered white space. So there's optional spaces before or after this. And there's other things you can do. You can input something like 0x23, and that'll be interpreted as a hexadecimal number. You could do 010, that'll be interpreted as an octal number. And that's what these scanners do for you, right? So when you scan something with a %d, it's going through all these possibilities and it's trying to nail down exactly, is this an integer or not? All right, and then some other comments in chat. So what is this new line? The new line is really just, it's another ASCII character. Every character is 8 bits. Okay, we're talking about ASCII, not Unicode, so this is old school. 8 bits, which is 1 byte. And those 8 bits represent a character. So character 65 decimal is an A. Character 48 decimal is a 0. Character 32 decimal is a space. Every character has a unique code. And these go from 0 up through 127. They're not all printable. And then 128 through 255 are different things. So character 10, that's a new line. And, anything that we put in single quotes, other than a single quote, is treated as a character. So how do we represent something that's not a printable character? I mean, we can't call it a backslash, we can't call it an N. So we use these combinations, this backslash followed by something, and this is not a single character. This is 2 characters, but the backslash says the thing that comes after this will tell you what character I want. So if you do a \n, that means a new line, that's character 10. Somebody else pointed out if you do a \t, that's a tab. That's ASCII character 9, that's a control I. If you do a \r, that's a carriage return, that's ASCII 13. If you do a \0, that's ASCII 0. The only reason that's a null terminator is because when people were putting together C and trying to figure out how to do strings, they decided, hey, let's use a null terminator. When DOS was put together, they used character 26 to represent the end of a file. There's nothing magic about character 26, that's just what they chose. So character 0 is used for the end of a string. You could have used a new line to end a string, but then a string could only contain characters that weren't a new line. So it's \0, ASCII code 0. And while we're here, if you do \\, that's how you represent a backslash. So this first backslash, that's sometimes called an escape character. I spent a few decades of my life working around the concept of an escape character. That's another story. But there's something really powerful about this. It basically changes the thing that follows it from something literal to something that's interpreted. All right, let's see what else in chat here. How do you print a $sign then? So you can print a $sign with just a $sign. Yeah, we don't want to talk about escaping characters in Bash. That's a whole another can of worms. All right, so the punchline here is kind of this business, right? But I don't want this to just be something that you memorize and use when you want to take out the new line at the end of an array, right? I want you to understand what this is doing. What I want to do tomorrow is dig into more things like this that we can do with strings, swapping the first and last character, swapping the first two characters, interleaving two strings, counting the number of occurrences of things in strings, writing our own string length function, stuff like that. So, and this will feed into ODPs for the end of the week. Let's see. Any other questions? I'm reading some more comments in chat here. Yeah, I don't know how you do that in DOS. The other thing worth mentioning here is that when you print, right? Normally we print strings with a %s, which means that the thing that we're passing should be a char star, a pointer to the beginning of an array, so the address of this thing in memory. And when printf sees the %s, it will go to this location in memory, grab this character, print it, grab the next location in memory, print it, keep doing that until it finds a location in memory that has a 0. And then it says the string is done, and it returns, or continues printing, whatever is next. But when you print with a %c, you have to give it an actual character. Character is a byte. It's an integer, a very small integer with an ASCII code. So if you were to just print a 65 as a %c, your terminal would print out the letter A. If you were to print character 0 with a %c, I think it prints something like NUL or something like that. Or maybe just a control @ or something weird. But characters have nothing to do with strings, per se. All right, cool. We are out of time today. All right, so we'll talk more about the midterm tomorrow. We'll go over lessons from the midterm and talk about next steps, and then we'll continue digging into string processing. ODP 408 does not need a specific executable name. You're just going to run it through the assess command along with your source code. So you can call it whatever you like, but never call it something like test or read or something like that. Make sure it's not a reserved keyword. So ODP 408 is totally safe for an executable name. All right, thank you everybody. I will see you next time.